Alright, so we did this is my original backwards lesson plan that I did, and it's on systems of linear equations. And my achievement, or my outcome, was to solve problems that involve systems of linear equations in two variables, graphically and algebraically. And I didn't focus on the graphic part in this. I assumed that that would be their prior knowledge, that they would have already learned how to plot the lines, and actually go about finding the intersection point. So then this was going to be the next lesson in which you would start learning about how you would do it algebraically. So the prior knowledge, you'd already know what a system of linear equations is, that two lines may cross once at all points or not at all. A bunch of other different things about linear systems that it's really important to learn, basically the graphing and what it looks like and what it actually means to have a solution to your linear equation. So our original essential questions here, I have, how can you create a linear equation in one variable from a linear system of equations? So that was something that you have to do with these algebraic substitution methods, is that you take a problem you don't know how to solve and you move it into a problem that you do know how to solve, which is a linear equation in one variable. And then essential question number 2 is, what does the solution to a system of linear equations represent? And how can you verify that your solution is correct? And then, are there times when it would be beneficial for you to employ one method of solution over another? If so, when? And if not, why? So that was something that I thought it was really important, because once you know both methods, substitution and elimination, there's really only certain times that you really need to use one or the other. And mostly it's a matter of preference. So what we did in our lesson is, I had a PowerPoint that I put up, and I asked students to volunteer to explain how you actually solved the equation, or the system of linear equations, with a graphing method. And then I asked them to try, or to say if it was easy or hard, and if they liked to do it, or if they wanted a different way to do it. And then I posed this example here about y equals x and y equals 13 over 3x minus 1. So then I showed them the graph, and I said, like, you look at this and it doesn't have a whole number intersection point. So it was hard for them to graph, so that's kind of why you need to have these other methods of solving them. So then, as a class, we went through a few examples of how you would do substitution, and we started with that one, basically arbitrarily, because it was something that they should already know how to do, is substitute something into another thing. And then after we had done that, let them work in pairs to verbalize the thought process for a couple of examples. And once they've done a couple of examples, I had 3 in my lesson, have them discuss the method they would use to ensure that the intersection point they found is right, and then do it as a class and ask if they would use technology. And then I just had some general ideas of how people would want to do it. Then I did the exact same thing with the elimination method, going through and doing one example as a class, then having them do it in pairs, or if they preferred, work individually for the other examples. And we did the exact same examples in each one so that they could see that both of the methods work equally well. And then after we had asking students what method they prefer, and then talking about essential question 4, which was which ones would be useful when and why, and then record the results so that you actually have something for students to reference. And then again, set some practice problems just for them to do. So what we basically changed in this lesson was we changed one of the essential questions, and we changed the focus on essential question 3 and 4. And then we also changed a few things within each section, the before, during, and the after of the lesson plan. And that's something that the other people will talk about. Are you going next?
Yes.
Okay. This is a lot heavier than I think it's going to be.
Oh, it's like this part. Okay, so as Allison said, we changed it to question number 2. So before it was talking about like something about a solution for the linear relation. Now we kind of wanted to just focus more on what does it mean for a point to satisfy both lines. So we changed it to that, and then we added we added these, right? Oh, we changed the emphasis. Sorry. It's been a while. Don't laugh. So anyways, we just changed the emphasis to cover more in depth in the actual lesson plan because we thought it was more important. Um, and this is purple, but you can't really see it. But it's we kind of just more made these for like adaptive dimension or to complete these next in class because we just didn't really, they weren't necessary. And then we didn't change much after that until we get to the actual like before, after, during stuff. So we kept that all pretty much the same except for down here, which we had them do a more hands-on approach instead of them just looking at it. So if they had like a better understanding of stuff, so we gave them the linear system above, and then we'd have them graph it and come up to the conclusion that it would be nice to have another way to solve this system. So they're doing it on their own. It's not just us being like, here you go, look at it. That's pretty much my part.
Wear this thing. There we go. Okay, so basically what we did is we took the lesson plan from before and we saw what elements we could add to it that would really engage the students. So I think what was lacking before was visual representations and hands-on stuff and using technology to engage the students. So right in the during, sorry, if I can use this thing. So we start off with, she gives them an equation, 2 equations, right? And instead of having them just plug in values to see where the intersection is, we would give a graph without any values on it so they can't just look by inspection and see the intersection point. Yet they can see visually that, hey, look, these graphs will collide at a point, so that when they do it on paper, they kind of have an idea what it looks like. And we can use this using Java applets, so you can actually like, manipulate the graph so they really have a feel of what's going on. So when we move before, after they finish their question, we would then add the points on the graph so they can check their answers themselves. So that then you actually could see where the intersection point is and see if it corresponds to what they got. And so throughout the lesson, when you're doing examples, we would encourage them to use technology, so like their phone or whatever, iPad, whatever you have, and put into like a Java applet the equation so they can check their answer and see what's going on. I think it's really important that they can see what it looks like. So when they look at equations, they can have a deeper meaning that way. And so elimination and substitution, our approach is similar. Actually almost the same, pretty much. So everything we did in substitution, we would do for elimination in terms of technology and visual representation, which probably gives it more structure for the students as well. So when they get to that part, they kind of have an idea of what to look for in a graph. And at the end, we would get the students to summarize what they learned. So that's something we would add to this lesson. To have like a journal entry or something, maybe like an exit slip, summarize what they've learned, what the visuals taught them, and what substitution and elimination are really in a deeper sense, instead of just, this is how you can find the intersection point, or, what does it look like, and stuff like that. So yeah, any questions? That's about it, right? Questions? Kelsey?